Hey guys, we're back at it with writing some equations of piecewise functions today. So before we can write our equations, we need to review how to write the equation of a line. So typically if you're given a line, like you have here on this picture, you're thinking y equals mx plus b. So you need the slope and the y-intercept in order to write the equation of a line. In our case, this line goes through 2, so our b value is going to be 2. Then our slope is going to be, let's see if we go from this point to this point, we're going to rise 1, 2, 3 and run 1, 2, 3, 4. So m is a positive 3/4 because we have something that's going uphill. So the equation of this line would be y equals 3/4 x and then plus 2. But then if you stop and think for a minute how things might change when I take this line, notice this still goes through 2, it's still a positive slope, we still rise 1, 2, 3, and run 1, 2, 3, 4. So it's still the same equation. The problem is now we're stopping. And so this is where our piecewise functions kind of come into play. This equation is true. Y is still 3/4 x plus 2. The problem is it's only for the x values that are less than 0. And so this is what we're going to use to help us put together our piecewise functions. So we've already talked in the last couple slides about y equals mx plus b. And so typically you're going to use that when you know the y-intercept. M is going to be our slope, b is the y-intercept. However, we may be looking at graphs where we don't necessarily know the y-intercept. So in that case, we could use a different form called point-slope form. And we use this typically when y-intercept is not known. And in this case, we have m as a slope, so we're going to plug in an m. And then we also need to plug in x1 and y1, which is just a point on the line. And so once we plug that in, we have to then rearrange and solve for y, and then we get the equation of our line. So let's give it a try. This first one, we have a line on the left, line on the right. So we're going to have to write two different equations. The one on the left, I can see the y-intercept, so I could use y equals mx plus b. So I'm going to say y equals mx plus b. I can see the slope, or the y-intercept is 3, so b equals 3. But here it's going downhill, so I'm going down 2 and over 1. So my slope is going to be a -2. So this first part of the line is going to be y equals -2x plus 3. Right? And that's going to be true for all the values where x is less than or equal to +3. All right, the other part. Let's see. So for the other part, I don't know the y-intercept. So what I'm going to do instead is use my y minus y1 equals m times x minus x1. So here I have to come over here and count my slope. So I'm going to say the slope is rise 3, run 2. So I have a slope of 3/2. So I'm going to plug that in here. And then we need a point on our line. So we need to plug something in for y1 and x1. So we could use this 3, 1. I know it's an open circle, but still if this line carried on forever, that'd be a point on the line. So you could choose that, or you could come over here and choose this point 5, 4. It doesn't matter. I'm going to use the point 3, 1. So x is 3, y is 1. So I'm going to have y minus 1 and then x minus 3. So it's always minus that x1 and y1. All right. I need to move the 1 over, but I also need to do something over here. I need to distribute that 3/2 to get y by itself. So I have y minus 1 equals 3/2x minus, so remember this is really like 3/1. And so if I multiply 3/2 by 3/1, I get 9/2. And so to that, I'm going to add 1 to get y by itself. And 1 we could write as a common denominator with this 9/2. It could be just a positive 2/2. So then my final equation for this part would be y equals 3 over 2x. Then we have negative 9 plus 2 is negative 7 over 2. So that would be the second equation, and that's for all the x values greater than 3. So I've got my two equations now, so I can write this as a piecewise function. So I'm going to say f of x equals, and I'm going to write this top function for the left side. So I'm going to say negative 2x plus 3, and that's going to be when x is less than or equal to 3. And then I'm going to take this other equation, 3 over 2x minus 7 over 2, and that's going to be for all the values when x is greater than 3. I'll give you a minute to digest that, and then I'm going to record another example for you to see and try out for yourself.